To the casual observer, the 1996 Grand Cherokee is very similar to the 1995 Grand Cherokee. The similarities soon vanish, however, when you look at the vehicle's electrical systems. Grand Cherokee's electrical system has been completely redesigned, and the information you have about many systems and components used previously no longer applies. Hello, and welcome to Part 1 of 1996 Grand Cherokee Body Electrical. In this month's program, we'll take a look at body electrical technical highlights. We'll cover power distribution, wiring and grounds, electronic modules, memory systems, and conclude with a brief rundown of new features. In Part 2, which is due out in December, we'll concentrate on diagnostics. Let's get started. There are two main power distribution points on the 1996 Grand Cherokee: the Power Distribution Center and the Junction Block. The Power Distribution Center is located under the hood on the right side of the engine compartment. It houses fuses and relays. Relays include the engine starter motor, intermittent wiper, ABS main, AC compressor clutch, ABS pump, fuel pump, automatic shutdown, horn, and the transmission control relay. The 100-way connector, fuse block, and relay center used in previous years have all been replaced by a junction block which is located behind the right cowl side trim. The front of the junction block houses relays, circuit breakers, and fuses. The junction block also serves as a distribution center for the vehicle's main wiring harnesses. A total of 15 circuits are grounded in 6 locations on the 1996 Grand Cherokee. 2 grounds attached to the front of the left fender side shield. 3 grounds attached to the right fender side shield. The 4-liter engine has 3 grounds attached to the front of its right side, and 1 ground attached to the rear of its right side. The 5.2-liter engine has 3 grounds attached below the generator and 1 below the AC compressor. 4 grounds attached to the floor pan to the rear of the driver's seat. 1 ground is attached to the frame crossmember to the rear of the passenger seat. And finally, 1 ground is attached to the right rear quarter panel. Like all other Chrysler vehicles in 1996, the 16-way data link connector is located under the instrument panel to the left of the steering column. New for Grand Cherokee is an outlet for electrically powered accessories located between the cigar lighter and the ash receiver. To access, simply lift up the plastic cover. The power outlet has a direct feed from the battery and is hot at all times. To get a good idea of how power is distributed, what circuits are grounded, and how wiring harnesses are routed, refer to Group 8W in the service manual. Before we take a look at electronic modules, let's reinforce what we've covered so far with a review question. Where are the 3 grounds on the 5.2-liter engine located? A, below the AC compressor, B, below the generator, or C, on the right side toward the rear of the engine? B is the correct answer. 3 grounds are located below the generator. There are up to 15 electronic modules on the 1996 Jeep Grand Cherokee, and 11 of them are on the C2D bus. The C2D bus is a system of data communication between controllers through a twisted pair of wires. Messages are transmitted and received by the various modules connected to the bus. The modules will only respond to applicable message IDs. These IDs are given a special code that prioritizes their importance, enabling the controllers to read and react to critical messages before reading and reacting to messages that are of lesser importance. This method of data transmission is used much more extensively on the 1996 Grand Cherokee than it was in the past. Data bus communication significantly reduces the complexity of the wiring in the vehicle and the size of the wiring harnesses. The electronic modules that are on the bus are as follows: the Powertrain control module, Vehicle Information Center, Automatic Temperature Control Module, Radio except the base model, Instrument Cluster, Body Control Module, Compass Mini Trip Computer, Airbag Control Module, Memory Seat Module, and the driver's door and passenger's door modules. Modules that are not on the C²D bus are the Speed Proportional Steering Module, Controller Anti-Lock Brake, and the Heated Seat Control modules. Many of these modules are either new or different from last year. Let's take a closer look at them. The Powertrain Control Module, or PCM, is located against the dash panel on the right side of the vehicle. As explained in new model highlights, the PCM is the new JTEC controller. 3 32-way connectors now take the place of the 60-way connector used on previous vehicles. And a new special tool, number 6934, is required to repair the connectors on the PCM. It is also used to repair 2 of the 3 connectors on the body control module. The Powertrain Control Module now supports OBD2. OBD2 is an onboard diagnostic system required by law to meet specific government regulations. The PCM is the heart of the onboard diagnostic system. It monitors the performance of emissions-related components and systems and informs the driver when an emissions-related component malfunctions or deteriorates to the extent that vehicle emissions may exceed certain thresholds. When illuminated, the malfunction indicator light indicates an emissions-related concern, and a flashing mill indicates that continued driving of the vehicle is not recommended. Use the scan tool to check for diagnostic trouble codes if the malfunction indicator light is illuminated or flashing. The 1996 Grand Cherokee now uses a body control module, or BCM, to control many of the body systems that previously used standalone modules. The BCM has replaced the following modules: chime, automatic headlamp, intermittent wiper, panel lamp dimming, and vehicle theft security. The BCM has also eliminated the need for a heated backlight timer relay and separate switches for the door courtesy and door ajar lamps. The BCM attaches to the back of the lower instrument panel armature to the left of the steering column. Unlike other vehicle lines that have base or premium BCMs, only one level of BCM is available for Grand Cherokee. This month's reference book lists all of the features that the body control module either provides or supports. BCM programmable features include horn chirp, low fuel audible warning, and headlamps on with wipers. These features are disabled when the vehicle arrives at the dealership, but can be enabled using the DRB3 scan tool. When horn chirp is enabled, the horn will chirp when the lock button is pressed on the key fob. The low fuel light and a warning chime will activate in low fuel situations when low fuel audible warning is enabled. And the headlamps will automatically illuminate when the wipers are turned on once headlamps on with wipers is enabled. This feature is only available with the auto headlamp option. The gauges in the mechanical instrument cluster, or MIC, appear the same as last year. Only a vacuum fluorescent display has replaced the mechanical odometer wheel in the speedometer gauge face. The MIC cluster will not generate diagnostic trouble codes, and gauge calibration is not adjustable. However, you can perform an actuator test using the DRB3 scan tool. The test positions all the gauges at their calibration points, lights all C²D bus controlled lamps, and forces the vacuum fluorescent display to count from 0 to 9. The mechanical instrument cluster now features a cruise-on lamp for the speed control system. The PCM requests illumination of this bulb over the C²D bus. When illuminated, speed control is on, but is not necessarily engaged. Another lamp that deserves mention is the airbag warning lamp. The lamp will illuminate under the following conditions. When the ignition is turned to run, the airbag lamp illuminates for 7 seconds and then goes out. This is called bulb prove-out. The airbag lamp also illuminates if the Airbag Control Module, or ACM, senses a fault in the airbag system and communicates this to the cluster over the C²D bus. Or if the ACM fails to communicate with the cluster for 5 consecutive seconds. It's important to note that if for some reason the airbag warning lamp illuminates, the cluster will keep the lamp illuminated for a minimum of 12 seconds. The airbag warning lamp also has a backup system. In the event that the cluster detects a failure in the lamp circuit, the cluster will use the seatbelt reminder lamp as a backup. If the airbag warning lamp or lamp circuit malfunctions, the cluster will flash the seatbelt reminder lamp for 20 seconds after the actual seatbelt reminder function has been performed. If there is a fault in the airbag system, the seatbelt reminder lamp will flash for 20 seconds and then remain on continuously until the fault is fixed. All the gauges and most of the indicator lamps of the instrument cluster are now controlled by cluster circuitry in response to C²D bus messages. The speedometer, tachometer, oil pressure, voltmeter, fuel, and coolant temperature gauges all operate in response to messages sent over the Databus from the Powertrain control module. The turn indicator, ABS, and cluster illumination lamps are the only lamps that are hardwired. And aside from the airbag warning lamp, which is monitored by the Airbag Control Module, all the other instrument panel indicator lamps are activated in response to messages sent over the Databus from either the Powertrain control module, the body control module, or a combination of both. Let's look at the low fuel warning lamp to get an idea of how these components communicate. The body control module relies on inputs sent over the C²D bus from the Powertrain control module to determine when the fuel level is low. Once it determines that the fuel level is low, the BCM sends a message to the instrument cluster over the Databus to turn the lamp on. When the lamp on message is sent, the BCM also sounds a single low fuel warning chime. Four radio systems are available for the 1996 Grand Cherokee: an AM/FM radio with cassette, an AM/FM radio with cassette and a 5-band graphic equalizer, an AM/FM radio with CD and a 3-band graphic equalizer, and an AM/FM radio with cassette, CD, and 3-band graphic equalizer. Aside from the base radio, all the radios are on the C²D bus and are capable of displaying faults and allowing certain actuation tests through the use of the scan tool. The two radio systems featuring CD players are available with remote radio switches located on the steering wheel. The right-hand switch is a rocker-type switch that controls the volume of the sound system. The left-hand control is a rocker-type switch with a push button in its center. For the radio, the left-hand rocker switch controls seek up and down, and the push button controls station preset select. These switches also have CD player and cassette functions. Refer to the owner's manual for details. When activated, the remote radio switches send a resistive multiplex signal to the body control module. Actually, much of the electrical communication on the Grand Cherokee is in the form of resistive multiplexing. Resistive multiplexing has the advantage of sending many commands along the same circuit. In the case of the steering wheel switches, each command is sent along circuit 709 to the BCM. The switches are wired in parallel with a resistor between each switch and ground circuit Z2. The resulting voltage signal along circuit 709 determines the command sensed by the BCM. Once it interprets the command, the BCM sends a message over the C2D bus to the radio, which in turn performs the desired function. The Vehicle Information Center, or VIC, includes a graphic vehicle outline, electronic display windows, and 2 control buttons. It receives input from hardwired sensors and from the powertrain and body control modules over the C2D bus. Door and lift gate ajar messages originate in the BCM, and check battery and transmission over temp messages originate in the PCM. The VIC is hardwired to the lamp outage module, which monitors the rear lamps. It is also hardwired to the turn signals and the washer fluid and coolant level sensors. To maintain consistency between the clock in the VIC and the clock in the radio, the VIC clock automatically synchronizes its minutes with the minutes in the radio's clock. Each front door contains a door module. Door modules are new to Grand Cherokee. They control memory recall functions, remote keyless entry, power door locks, power windows, power mirrors, the illumination of window and mirror directional switches, and door courtesy lamps. Door module programmable features include rolling door locks and RKE door unlock sequence. The vehicle arrives at the dealership with these features disabled, but they can be enabled using the DRB3 scan tool. When the rolling door lock feature is enabled, the doors will automatically lock once the throttle opens at least 10% and the vehicle reaches 15 miles per hour. If the RKE unlock sequence remains disabled, the first unlock key press on the RKE transmitter will unlock the driver's door, and the second press will unlock the front and rear passenger doors. When the RKE unlock sequence is enabled, the first unlock key press on the RKE transmitter will unlock all the doors. The door modules use multiplexing to simplify wiring. Over 70 circuits have been eliminated, and a 14-way connector from the body to the doors has replaced the 30-way bolt assist connector that was used in '95. Aside from simplifying wiring, the door modules now carry out the functions previously performed by a keyless entry receiver in the overhead console, a front door jumper harness, and a separate auto down window module. Let's take a look at 2 systems under door module control: power windows and power door locks. As on previous models, the power windows have a lockout switch that prevents operation of the windows from any switch except the driver's door. But now, when this switch is pressed, it also shuts off the individual door switch LEDs. A new feature of the power window system allows the windows to be operated from any window switch for 30 seconds after the ignition switch is turned off, as long as neither front door is opened. Power windows also feature express down for the driver. When the driver presses the down switch to the second detent, the window will travel all the way down, even if the switch is released. To stop the window, simply press the switch momentarily in either direction. Power door locks can be operated 3 different ways: automatically by enabling the rolling door lock feature, or manually by activating either the front door switches or the remote keyless entry transmitter. The passenger door module contains the RKE receiver. When it receives a valid signal from the RKE transmitter, it will send a signal on the C2D bus to lock or unlock the doors. The RKE transmitter uses radio frequency signals to communicate with the passenger door module, and its range has significantly increased over the 1995 model. New for 96 is a panic button on the RKE transmitter. When pressed, the vehicle's horn will sound and the lights will flash for about 3 minutes, or until any one of the 3 transmitter buttons is depressed. We've just looked at the features of several electronic modules on the 1996 Grand Cherokee. Here's a review question to test what we've learned. Which of the following electronic modules are not on the C2D bus? A. Controller anti-lock brake. B. The automatic temperature control module. Or C. The compass mini-trip computer. A is the correct answer. Controller anti-lock brake is not on the C2D bus. The memory system is an optional system that allows the driver to save his or her desired seat and outside mirror positions and 10 AM and 10 FM radio station presets. Settings for 2 drivers can be stored. The memory system comes with 2 remote transmitters. The transmitters are numbered on the back and work in conjunction with the number 1 and 2 memory buttons on the driver's door. Once the memory button has been set, the corresponding remote keyless entry transmitter is also set. Positions can be recalled from either the door-mounted memory switches or the remote keyless entry transmitters. To program the memory system, adjust the seat, recliner, lumbar, and side view mirrors to the desired positions. Turn the ignition on and preset 10 AM and 10 FM stations. Press and release the set button. An indicator light on the set switch will flash telling you that you are in driver set memory mode. Depress either the number 1 or 2 switch on the driver's door depending on which transmitter you're using. Once the flashing indicator light on the set switch goes out, the memory positions and radio stations have been set. A C2D bus message is sent from the driver's door module to the memory seat module, passenger door module, and radio. It identifies the current seat and mirror positions and tells the radio to store the current presets and current station. The radio will confirm that it has received the C2D message and indicate 1 select or 2 select on its vacuum fluorescent display. Pressing the number 1 or 2 memory switch on the driver's door or the unlock button on the RKE transmitter will recall stored positions. If the memory recall request is initiated by an RKE transmitter, the RKE receiver in the passenger door module will signal the driver's door module over the C2D bus, which in turn signals the memory seat module, passenger door module, and radio to recall stored settings. Since the ignition is off during RKE operation, the radio will miss the recall message because it does not wake up on a bus bias. Once the driver's door module receives an ignition on message, it will resend the memory recall message, which is then acted on by the radio. The radio will confirm that it has received the message by indicating 1 select or 2 select on its display, mute, and tune the radio to the last station it was on. Memory seat recall is inhibited if either the driver's seatbelt is buckled or if the vehicle is in motion. Before we move on, here's one last review question. True or false? If the ignition is not on when recalling a memory position, radio presets will not be recalled. The correct answer is false. If the ignition is off, the radio will miss the memory recall message. However, once the driver's door module receives an ignition on message, it will resend the recall message. We've already discussed many new body electrical features, but there are still a few that we haven't covered. Let's start with the headlamps and work our way toward the rear of the vehicle. If the vehicle is equipped with auto headlamps, the lamps will automatically turn on in low ambient light after the engine is started. The lamps turn off once the ambient light sensor indicates sufficient light. The ambient light sensor, which is a photodiode, is located on the upper dash panel. It is part of a unit that also contains a light-emitting diode, which serves as the set or armed indicator for the vehicle theft security system. Auto headlamps include a new feature called Auto Parade or Funeral Mode. When the park lamps or headlamps are manually activated during the daytime, all of the vacuum fluorescent displays will remain at full daytime brightness to allow for greater visibility. This feature does not affect the incandescent lighting levels. Headlamps on with wipers is another feature included with auto headlamps. To function, the headlamp switch must be set in the automatic position. When the wipers are activated, the headlamps will automatically turn on. Regarding the wipers, intermittent wipe delay times are now speed sensitive. Above 10 miles per hour, the delay is adjustable from about 1/2 second to about 18 seconds. The BCM doubles the delay time when the vehicle goes below 10 miles per hour. Heated mirrors and heated seats are two features that will make life a little more bearable for customers in cold climates. Heated mirrors are activated whenever the rear window defogger switch is pressed. They are controlled by the door modules via a C²D bus command from the body control module. Heated seat control modules, which are located under each front seat, control the front seat heat levels. Each module controls its respective seat. The controls for the heated seats are located on the instrument panel to the right side of the steering column. The choices are off, low, and high. When servicing the system, keep in mind that heated seats will not operate above a certain ambient temperature. Besides the remote radio switches we mentioned earlier, the steering wheel also has a new clock spring and horn switch. The horn switch is now integral to the airbag cover. A passenger airbag is new for '96. Instead of a conventional pyrotechnic device, it relies on a canister of compressed gas to inflate the bag. To remind drivers that their turn signals are on, a new turn signal chime will sound after the vehicle has traveled about a half mile with the turn signal on. Also new for '96 is an electrically powered sunroof and a flip-up glass for the liftgate. The last feature we need to discuss is the HomeLink universal transmitter. The HomeLink transmitter is located on the driver's visor. It can replace up to 3 remote controls for devices like garage door openers, motorized gates, or home lighting. The transmitter operates off the vehicle's battery and charging system, so no batteries are needed. The programming procedure for the HomeLink transmitter is outlined in this month's reference book. Well, those in a rather large nutshell are the body electrical technical highlights for the 1996 Grand Cherokee. I'm sure you'll agree that a lot has changed from 1995 to 1996. We'll be back for part 2 of our Grand Cherokee Body Electrical program when we'll be discussing diagnostics. See you then.
Hey Mike, can you help me out here?
Sure, what's the matter?
I'm having a problem figuring out why the left rear door lock doesn't work.
Well, I see you're using the diagnostic manual and the DRB3 scan tool. Looks like you're halfway there.
Looks can be deceiving. I'm still not exactly clear on how all these electronic modules work together.
I'll tell you what, why don't you help me out with this month's MasterTech, Grand Cherokee Body Electrical Part 2. The focus is on diagnostics, so by the end of the program, you should feel pretty comfortable diagnosing any electrical problem on the Grand Cherokee.
Sure, that'd be great.
Okay. Grand Cherokee Body Electrical Part 1 highlighted electrical features. And a topic that was hit on again and again was vehicle communications over the C²D bus.
Yeah, I remember. It seems like all communications go over the bus.
Well, not all. The base radio, controller anti-lock brake, speed proportional steering, and heated seat modules don't communicate over the bus, but all the other modules do. 3 modules that play key roles in Grand Cherokee's body electrical system are the body control module and the driver and passenger door modules. Now, if you look on pages 4 and 5 of October's reference book, you'll see just how many features the BCM either provides or supports.
Wow, that's quite a bit.
Well, it really is. But what's equally important to understand is the way in which the messages controlling these functions are sent.
You mean resistive multiplexing?
Exactly. Resistive multiplexing minimizes the vehicle's wiring by controlling many functions over the same circuit.
I remember the remote radio switch example in the video. The BCM translated the voltage signals from the steering wheel switches and then set the appropriate command to the radio.
That's right.
You mentioned door modules. I know that they play a key role in the door lock problem I'm faced with right now.
Well, that's true. But besides controlling the power locks, they also control memory recall, remote keyless entry, power windows and mirrors, the illumination of window and mirror directional switches, and the door courtesy lamps. But we'll get to that a little bit later. If we want a thorough understanding of how to tackle this vehicle's body electrical system, we have to start at the beginning, the manual. Once we cover the Body Diagnostic Procedures Manual, we'll proceed to the DRB3 scan tool operation, and then work on the door lock problem you're faced with now.
Sounds good to me.
All right then, let's get started. The Body Diagnostic Procedures Manual is a bit different from last year's, so it's a good idea to review the entire manual prior to jumping into any diagnostic procedure.
It doesn't look like a quick read. How much time do you recommend?
Well, enough time to understand how the manual works, which shouldn't take too long. The focus of the manual is Section 7, Diagnostic Information and Procedures. The sections leading up to Section 7 and those following both provide general information.
Well, I can see they've labeled general information sections in the side margin. Is there anything special I need to know about the general information sections?
Well, Sections 3 and 4 can be pretty helpful. Section 3 describes the various electrical systems on the vehicle and also provides diagnostic trouble code information. Section 4 provides component locations and their connector pinouts. Another section that can be helpful is Section 10, schematic diagrams.
The most important section, though, is Section 7, right?
Well, it's the section you'll use most often. It's where all the diagnostic tests are located. The most important thing you need to remember about Section 7 is to always start troubleshooting by performing Symptom ID Test 1A.
Why is that?
Well, by doing so, your chances of error are greatly reduced. In addition to diagnostic trouble codes, Test 1A is driven by symptoms and will consistently lead you to the procedure that corresponds to the symptoms you're experiencing. Just find the system you're troubleshooting at the bottom of the page, and the Symptom ID Test 1A directs you to the appropriate test.
Okay.
Use the side headers or the table of contents to locate the system. The systems are arranged alphabetically. Once you find the system, look up the test.
Okay, let me work through this with the diagnostic trouble code to make sure I understand.
Okay, go ahead.
Let's say I perform step 3, read DTCs, and trouble code horn relay short is displayed on the DRB3 scan tool. I'm then directed to symptom ID test 1B. Horn relay short in test 1B directs me to vehicle theft security system test 4A. I could use the table of contents to find vehicle theft security, but instead I'll use these side headers. And once I'm in the Vehicle Theft Security System section, I just have to find Test 4A. And as it turns out, Test 4A is repairing the VTSS horn circuit. I then perform the steps in the flow chart until I make the repair. Well, this seems simple enough. Is there anything else?
Just one more thing. After the repair has been made, the manual will then direct you to a verification test located at the end of Section 7. For example, let's say that you finished Test 4A by replacing the body control module. The asterisk in the last flowchart box refers you to the bottom of the page, which then directs you to Verification Test 3A, which is on page 517. The verification test ensures that you complete the last step of the 6-step troubleshooting procedure, verify operation. Now, before we move on, let me ask you a question, which I'll also direct to the audience in general. Where in the Body Diagnostic Procedures Manual should you always begin when troubleshooting?
Well, that's easy. Symptom ID, test 1A.
Well, it's easy, but important. Remember, if you always start at symptom ID test 1A, you're less likely to make mistakes. All right, let's move on to the DRB3 scan tool. I'm sure you noticed when you were working earlier with the DRB3 scan tool that there are a lot more functions concerning the Grand Cherokee than there were last year.
Actually, I think that may have led to some of my confusion. I'm not used to relying heavily on the scan tool when working on Grand Cherokee's body electrical system.
It's true that you'll have to use it a lot more now, but when you realize how helpful it is, I think you'll grow to appreciate it more. The same rule regarding the Body Diagnostic Procedures Manual holds true for the DRB3 scan tool. Begin with Symptom Identification Test 1A. The test leads you through the hookup procedures, and if there is a malfunction with the scan tool, the Body Diagnostic Procedures Manual will direct you to the appropriate corrective steps. When diagnosing the body system, the first 3 steps are always the same. Let's follow along.
Okay?
Connect the DRB3 to the data link connector. Then turn the ignition on. Select Standalone DRB3. Select Body System, then Body Computer. Step 2 in Test 1A gives you directions if the DRB fails to display bus operational, or if the display is no response. Now select Read DTCs. If any trouble codes are present, go to the Symptom Identification Test 1B.
And if no trouble codes are present, but I'm having problems with a particular system, the list at the bottom of Symptom ID Test 1A will direct me to the appropriate system test. So I should go through this procedure every time I'm working on the body system with the DRB3?
That's correct. Now, let's explore some of the diagnostic capabilities of the DRB3 scan tool. Let's first go back to the main menu. Select option number 9, Customer Preferences. This allows you to enable programmable features and to program the RKE without having to go into the body system. In the October MasterTech, we discussed the customer programmable features that are enabled at the dealership.
You mean like rolling door locks?
Well, that's one of them. Now, the others are low fuel chime, auto headlamps with wipers, RKE horn chirp disable, and the RKE door unlock mode. You can also enable these features by going into the body system. Okay, let's get into the body system. The screen you see now is a standardized screen for all Chrysler vehicles, so some of the options won't apply to every vehicle. For example, since the Grand Cherokee has a mechanical instrument cluster, the electronic instrument cluster listed wouldn't apply.
The same must be true about the Compass Mini Trip computer. Grand Cherokee doesn't have Otis or Compass Temp.
Exactly. Another thing to keep in mind on this particular screen is that there are 2 screens. Hit page forward, and page 2 displays the memory seat module, door modules, and the vehicle information center. All right, let's go back to page 1 and get into the body computer.
Okay.
After you select body computer, select module display. This screen will tell you 2 things: whether the Vehicle Theft Security System, or VTSS, has been enabled, and whether it's been initialized. VTSS is initialized after 20 engine starts. If it's not enabled or initialized, the DRB screen will not say with VTSS. Let's go back to the previous menu. The monitor display is useful because it allows you to concentrate on specific areas of concern. For example, let's say you're working on the wiper system. Wiper System Monitor will display a lot of information regarding wiper operation. All right, go into the Wiper System Monitor. Notice what happens to the park switch as the wipers move.
Well, the switch changes states. The switch closes when the wipers are down and opens when the wipers move up.
Another thing you can check is intermittent operation. Look at the intermittent wiper relay display.
Oh yeah, I see. The relay is off when the wipers are down and turns on when the wipers move.
Now, do you see how the monitor display can be helpful?
You bet. It's a quick way to find out if the relays and switches are operating correctly.
That's right. And you can use the monitor screen in combination with the actuator test screen to narrow down causes of potential problems. All right, try the wiper actuator test. All right, here's a hypothetical situation. Let's say that the wipers work when the actuator test is performed, but don't operate when activated from the switch. All right, what causes can you rule out?
Well, since the actuator test activates the wipers, we know that the wiper motor's working, so we could rule that out.
That's good. You'd also probably want to go back to the monitor screen and check out the switch states to see if the problem is in the switches as you depress them.
The body diagnostic manual should lead me to the cause regardless, though, right?
Of course. But what we're doing now is just getting a feel of the scan tool's usefulness in troubleshooting situations. You should always use the scan tool in combination with the body diagnostics manual. Now, I mentioned earlier that the programmable features can also be activated when you're in the body system. All right, select Miscellaneous.
Not all the programmable features are displayed.
That's because we're in the body computer system. The body computer only controls low fuel chime, enable VTSS, RKE horn chirp, and auto headlamps with wipers. Auto door locks and the RKE functions are controlled by the door modules. To get to the door module screen, we have to go back to the body system screen.
No problem.
All right, now select Door Modules. Then select Sensors. Sensors is a very functional screen,
Oh, wow, you can actually check current draw.
but the windows must be operated from the driver's door switch in order to read current draw.
What about the input-output option?
Well, let's check it out. All right, the input-output screen shows the switch states for the locks and windows. However, only driver and front passenger door switch states are shown.
I see the door modules also have an actuator test. I guess you could narrow down potential causes of a problem by using the input-output screen along with the actuator test, which is similar to what we did in the body computer system.
Hey, you're catching on fast. You know, I think we're ready to put what we've learned into action and tackle the door lock problem you were working on earlier.
Let's do it.
Okay. I'll tell you what, why don't you lead me through the diagnostic steps? I'll help you out if you run into problems or have any questions.
Sounds good. Well, I guess the first step in any problem is to verify the complaint. So let's make sure the left rear door lock is not working.
Well, the left rear door lock doesn't seem to work, and I've tried both switches.
Well, let's proceed with diagnostics, beginning with symptom ID test 1A in the body diagnostic manual. With the DRB3 scan tool connected and the ignition on, select body, then body computer. Okay. Now select read DTCs.
Well, no DTCs are recorded.
Since no trouble codes are recorded, I go to step 4. The problem is with the power door lock system, so we need to perform power door lock test 1A, which starts on page 240.
Now, I don't mean to interrupt, but the wiring diagram on page 240 provides us with a good opportunity to go over how this system theoretically works.
Hey, feel free to jump in anytime.
Thanks. All right, first of all, it's important to understand which modules control which locks. The driver door module controls only the driver door lock motor. The passenger door module controls all the others, including the left rear. It's also important to know that the door lock switches are integral to the door modules. All right, just by looking at this schematic, you can get a good feel of the roles the driver and passenger door modules play. When the driver power lock switch is activated, the driver door module activates the left front door lock motor and sends a bus message to the passenger door module, which then activates the other door lock motors. Conversely, when the passenger power lock switch is activated, the passenger door module activates the right front, right rear, lift gate, and left rear door lock motors, and also sends a bus message to the driver door module, which in turn activates the left front door lock motor. Now, to make sure we understand this setup, let's try a hypothetical. What is most likely the cause if the following conditions are present? The driver's power lock switch only activates the left front door lock, and the passenger's power lock switch activates all the locks except the left front door.
I'd have to say there's a problem in the C2D bus circuit between the driver door module and the passenger door module. Since each module can only activate its hardwired lock motors, something is preventing the modules from sending messages to each other.
Right. Well, good job. All right, just keep in mind that the Body Diagnostics Procedures Manual would have also led you to the same conclusion. Here's a question that hits closer to home. What can we rule out as a cause for the problem we're diagnosing now?
I think we can rule out problems with the driver and passenger door modules. Since the other locks operate when activated from either module, I would think that the problem is due to a bad left rear lock motor circuit or the motor itself.
Well, let's see if you're right.
Okay, well, to continue on, we need to get into the door module screen on the DRB3. Lower both front door windows. Remove the key from the ignition switch and lock and unlock the doors from both door switches.
I take it we're verifying the complaint according to the test.
Right. And it looks like we've come to the same conclusion. The left rear door lock is the only lock that's not working. According to step 4, we have a problem when one door fails to lock and unlock. So we need to perform test 2A. Test 2A tells us to do the following. Disconnect the left rear door lock motor connector and probe the lock driver circuit with a test light. Okay, Mike, let's see if the light flashes when I use the actuator test to activate the lock relay.
Okay, go ahead. Yeah, it lights.
Now we have to probe the unlock cavity. Again, let's see if the light flashes when I activate the unlock relay.
No, it doesn't light up. I'd say we have a problem with the unlocked circuit.
Looks like we have an open circuit.
Well, judging from the schematic on page 242, the open must be somewhere between the liftgate lock motor unlock circuit splice and the connector to the left rear door lock motor.
We're going to need the service manual for a little more detail.
You're right. Let's take a look.
Since all the locks operate except the left rear, the open must be between connector C381 and splice S308.
It'll probably be easiest to work from the motor to the splice instead of the other way around. So let's check if the open is between connectors 381 and 309 first.
381 is the connector to the lock motor, which is already disconnected. So we just need to disconnect 309, which is the body to door connector, and check for continuity along the unlocked driver circuit between the connectors.
Nope, there's no continuity. It looks like we've isolated the problem.
We just need to find the brake in the harness. Well, I'm happy to say that the harness has been repaired.
Great. We just need to perform verification test 2A. If everything checks out, we've solved the problem.
According to verification test 2A, we must do the following. Reconnect all disconnected components, turn the ignition on, erase any trouble codes using the DRB3, and finally, turn the key off, wait 10 seconds, and then turn the ignition back on. And now for the moment of truth. Let's see if the lock works.
Never a doubt in my mind.
Well, there's still one step remaining, and we need to check if there are any body control module trouble codes present.
No trouble codes present.
We've solved the problem then. This really wasn't as difficult as I originally thought. Thanks for clearing things up.
Happy to oblige. As long as you stick to the procedures in the manual and have a good understanding of the systems involved, diagnostics won't be a problem. Well, that takes care of this month's program. We'll see you next month on MasterTech.